Hello all. We shall be starting with our experiment number 8, that is to draw the IV characteristics curve of a PN junction diode in forward and reverse bias. First of all, let us understand what a PN junction diode is. So basically, PN junction diode is made up of a P-type semiconductor and an N-type semiconductor. P-type semiconductor is the positive type semiconductor, which is because of the presence of trivalent impurities in it, because of which the number of holes in the p-type semiconductor is more than the number of electrons. And in n-type semiconductor, which is the negative type semiconductor, the concentration of electrons, that is the negative charge, is more than the number of holes, or we can say in other words, in more specific terms, that the number density of holes is more in the p-type semiconductor, hence it is called the positive type, and the number density of electrons in the n-type semiconductor is more than the number density of holes, hence it is called the negative type. So when these two are fused by certain techniques, like for example heating a wafer of a trivalent impurity on a pentavalent impurity will make the upper surface, that is the upper part of the wafer, as say the p-type, because of a presence of a trivalent impurity. And there are many other ways by heating it in an atmosphere of the other impurity, and there are so many methods which you have already read in the theory. So whenever this kind of junction is created, the boundary or the junction will have some flow of charge carriers, because we know that on one side, that is on the p side, the number density of electrons is less and the number density of holes is more, whereas on the other side the number density of holes is less and the number density of electrons is more, because of which certain transfer will take place. Certain transfer of, this is say p type, this is say n, and the triangle, this part is the p type and the other side is the n. What happens in the p side, we have more number of holes, number density of holes is more here. So I'm going to draw it as hollow, and here we have more number of electrons. So what will happen, the electrons are going to flow from here to here, and that will lead to the formation of a region here, which is the depletion region. So why is the depletion region created near the junction? That is because, first of all, who will migrate? The one near the border. So that is why a stage will come when this end will become slightly positive and this end will become slightly, when electrons come here, then this end will become, that is the p type, this is the junction. So because of the diffusion of electrons from n type to p type, this will become slightly negative and this will become slightly positive, and you will, when you see it, you will be seeing a region where the negative carriers are on the p side and positive, that is the holes, are created on the n side because of the flow of diffusion current. And then a reverse to this, what will happen now, because the diffusion current has created this, now some electrons are going to flow from here to here, because there is a negative charge here, there is a positive charge here, and this is drift current. And after that an equilibrium is reached, and you will see that still some charges, that is negative, is left on this side, on the p side, and positive is left on the n side. This region is called depletion region, which will prevent the further flow of electrons. These negative charges are going to prevent the further flow of electrons from n side to p side, and these positive charges are going to prevent the flow of holes from p side to the n side. So this depletion region will have certain potential difference across it, and this is called barrier potential, which we are going to call as VB. This barrier potential is going to prevent any flow of charge carriers between the p and n side. So I hope you have understood what the background of p and n is, and what is the junction, and what is this barrier potential, which is preventing any flow of charge in the junction. So what is forward bias? So in forward biasing, as we can see, the terms are used here: forward bias and reverse bias. In forward bias, the P side is connected to the positive terminal of the battery and the N side is connected to the negative terminal of the battery. And then when we move this is called the forward biasing. When the battery is connected, this is the forward biasing. In the reverse biasing, the reverse happens, that in the P side we are connecting the negative of the battery, and to the N side we are connecting the positive of the battery. This is called reverse biasing. In forward biasing and in reverse biasing, there are certain characteristics. When we increase V, the current will increase in a certain way. That is what we have to plot in this experiment. I'll show you how the circuit looks like and how do we need to plot it. So hello students, we are going to learn about how to draw the IV characteristics for a PN junction diode by using this apparatus. So I'll just show you how the junction is connected in series in forward as well as reverse bias, and then we are going to draw a graph for IV characteristics for forward as well as reverse. Now you see the connections. As this is a PN junction diode in the forward bias, so positive of the battery to the P side, then an ammeter is connected in series with the positive, the negative of the battery is connected to the negative of the ammeter, and the voltmeter is again connected in parallel with the battery. This is how the connection should look like. When we shall be doing the forward bias, we will be taking 3 volt DC and we shall be taking the readings of the ammeter in milliamperes, because there will be a considerable amount of current flowing through it. So I'll just show you how to take the readings, and our aim here is to find the threshold voltage. Three volt milliampere. Now you see, I'm going to slowly increase the voltage and I'm going to find out the stage when the cutoff voltage is achieved or the threshold voltage is achieved. So I'm going to slowly increase V and see when the current starts to come in picture, and that comes out to be at around, if you can see, I'm going back, it comes out to be around 0.7. It is the time when the current starts to come up in the PN junction diode, and then as I slowly increase V, my I also keeps on increasing. So I'll be taking some about 10 to 15 readings up to saturation current, which is coming out to be around, it will keep on increasing. So I'll be getting in, and you're seeing that initially the small changes were not proportionate to the growth in current, but as I'm increasing the V, later on the current is exponentially growing. That is all for the forward bias of the PN junction diode. Now I'll show you how to make it into a reverse bias circuit. You see, I'm going to connect the P side initially, and I'm going to, you have to see, in different instruments you will be getting different polarities, so you have to take care that positive of the battery now is connected to the N side of the diode and the negative is now connected to the P side of the diode, and now it is become a, you can see the connections, now it has become a reverse circuit, or it is the reverse bias circuit now. The major adjustment now we have to do is, now since in reverse bias the resistance is very high, so I'll be increasing the voltage because the current will not be able to flow, the resistance is very high. So I'm going to take 30 volt DC, I'm going to switch to this to 30 volt DC, and since the current flowing will be very less, so I'm going to take it as in microampere now. Instead of milliampere, I'll be switching it to microampere, and then we are going to take the readings to find out the reverse breakdown voltage. Initially the current will not increase, and after a certain point the current will exponentially become very high. So that is the aim to find out. So we shall very slowly begin. You see, on increasing V, there is no current flowing in it, no current. Then some current starts to flow on slowly increasing V, and that current is very very less since we are reporting it in micro ammeters, in microamperes. You see somewhere around 28, 29, you see there is a sudden increase, and that is the breakdown voltage, that is about 28 volts in this case. So that is all you have to plot IV characteristics for a PN junction diode in forward as well as reverse bias. When we slowly increase the voltage in forward biasing, we'll see that the current is not increasing, and then there is sudden increase in the current. This is the knee voltage or the threshold voltage, and then the current increases considerably and reaches saturation. That is all for forward biasing. In reverse biasing, you see the current is plotted in microamperes. In forward biasing, the current was in milliamperes. When we increase the reverse voltage, we see that there is very slight increase in the current, and that is also in microamperes. So it is in 10 raised to the power minus 6. And then there is a sudden exponential increase in current here at this point. So this is the reverse breakdown voltage. These are the values which you have to find out. Also, before doing the experiment, you have to write all these things, that what is the least count of the voltmeter. There are two least counts here. The same thing goes for milliammeter and microammeter. For that both you have to write the least count. How you are going to make the observation table? You have to take more readings. I have shown very less of it here. Try to take 10 to 12 readings in reverse. So initially in forward bias, these two columns are for forward bias, these two columns are for reverse bias. We are going to draw IV characteristics. So we'll slowly increase the voltage in forward bias, and then for the increase in the voltage, there is a considerable amount of increase in the current also, and the current will at some point of time reach its saturation. In reverse breakdown, in reverse bias of the PN junction, we are going to increase the voltage considerably, not in small chunks, and a stage is reached when you will see that initially the growth was very small, 6, 8, 8, then 10, 12, 12, and the sudden breakdown will take place, and that is called the reverse breakdown voltage. For that voltage, there is a sudden amount of surge in current, exponential increase in current. That is what you have to find out in the reverse biasing of a PN junction. This is how the graph will look like. You have to make the combined graph here in milliampere and here in microampere, the forward bias and the reverse bias. Some precautions that are to be taken is that, first of all, double check if the junction diode is working or not, and before switching on the main thing, you have to see if in the forward and reverse bias, as I had explained before, that in forward you have to not take 30 volt, you have to take 3 volt only, and the ammeter reading should be taken in milliamperes, not in microamperes, because the current is huge in forward bias. Same thing in reverse bias, you have to take the voltage in 30 volt and the current in microamperes. So keep this thing in mind. Rest, if there is anything that I have left out or missed out, or you have a doubt in, please feel free to write in the comment box. Even if you like the video, please write your comments. That will really help us to work further and make better videos or edit the video. I'll try to write back to you as soon as possible, and please do share with your friends and people in need, and I hope everything was clear. Thank you.